Hi gang, welcome back. This is Mr. Strickland, and we're going to grind our way through deriving kinematic equation number 4, the last of our major kinematic equations that I want us to deal with. Let's start out by recalling what average velocity is. The average velocity of an object is equal to its displacement divided by the time it took for the displacement. So we can write that as velocity equals displacement divided by time. If we multiply both sides of the equation by t, we can say then that displacement of an object is equal to its velocity by the time. Now I want you to turn back in your composition books to when we did kinematic equation number 2. And what I'd like for you to do is remember that the velocity of an object can be described as the initial velocity plus the final velocity of an object divided by 2. And so what we intend to do when I move to the next page here, we're going to take this equation, well, let me back up there a little bit, circle this correctly. We're going to take this notation and move it into this spot into the equation. All right? So let me flip the page and then you'll see what I'm doing there. So now when we go back in here, we can say that displacement is equal to the initial velocity of an object plus the final velocity of an object divided by 2 times rate times time. Now, at this point what I'd like you to do is turn back in your composition books and look at kinematic equation number 1. What I want you to do is remember, if I could spell correctly, this would work better, wouldn't it? Remember that the final velocity of an object is equal to the initial velocity of an object plus the acceleration times time of that object. And if we rearrange this equation algebraically and solve for t, so now solving for t, here's what we get. T equals the final velocity of an object minus the initial velocity of an object divided by the acceleration. And I bet you can guess what we're going to do now. What we're going to do at this point now is take this representation and we're going to substitute it in for t here in the equation we were working on. So I'm going to move to the next page and put that in there. So now what we should be seeing is that we have the displacement of an object can be described as the initial velocity plus the final velocity divided by 2 and multiplied by the final velocity of an object minus the initial velocity of an object divided by the acceleration. And now let's combine some terms here, just do some simple algebra. And what we should see is that the final velocity squared minus the initial velocity squared over 2a. We just multiplied the top together and the bottom together for that. All right. Now there's a number of ways we can rearrange this this equation now at this point. We can multiply both sides times 2a and get 2a times the displacement equals the final velocity squared minus the initial velocity squared. Alright, that's one thing we could do. Now I'm going to go to the next page and we'll continue playing with this a little bit. Alright. So now, by just doing some algebra, let's isolate final velocity. So the final velocity of an object squared equals the initial velocity squared plus 2AD. Now to get rid of the square, we could say then that the final velocity of an object is equal to the square root of the initial velocity plus 2AD. Alright, and so that's going to kind of wrap up. That's our last major kinematic equation that I wanted to show you guys. Now we don't always have to use just this last one. When you look at this, and when you go back through here, any of these equations that we might seem to need in a particular situation, we can use those and manipulate them as we need to. All right. So while we're at it, I promised you guys 5 kinematic equations. So I'm going to move over here, and the last one, after all the work we've done over the last few days, is really kind of anticlimactic. So equation number 5 is really pretty simple at this point. Let's just go back and remember that the acceleration of an object can be described as the change in velocity divided by the change in time. All right, and so just real quickly then, the acceleration is equal to change in velocity over change in time. All right, and there you go. That wraps up our 5 kinematic equations that we're going to need to work in 1 and 2 dimensions. So we're going to stop there. Be sure you put this in your composition book. I would advise you to put this on the right-hand side of the page. Go ahead and make some Cornell notations on the left-hand side of the page. In the next video, I'm going to work a couple of sample problems for you to help you through some of your homework, and then we'll talk about it in class. So there you go.